Now welcome. Now we will see problem 5. Sketch the Bode plot for the transfer function gs is equal to ks square divided by 1 plus 0.2s into 1 plus 0.02s. Determine the value of k for the gain crossover frequency to be 5 radian per second. Now this is our problem. Now gs is equal to ks square divided by 1 plus 0.2s into 1 plus 0.02s. Step 1. Identify the factors. First, k is unknown, so drawing Bode plot without considering k initially. 2 zeros at origin, that is s square in the numerator. Then 2 simple poles, that is 1 divided by 1 plus 0.2s with t1 is equal to 0.2. Therefore omega c1 is equal to 1 upon t1 is equal to 1 upon 0.2 is equal to 5 radian per second. Another simple pole 1 divided by 1 plus 0.02s with t2 is equal to 0.02. Therefore omega c2 is equal to 1 divided by t2 is equal to 1 divided by 0.02 is equal to 50 radian per second. Now we will draw or we will write down magnitude plot table. Therefore magnitude plot table, serial number, factors, resultant, slope in dB, start point, end point. Now first factor is k. Its slope is always 0 dB. Starting point is 0.1, infinity. It is parallel to x-axis. Now second factor, 2 zeros at origin, that is s square. It is contributing a slope of plus 40 dB per decade. Starting point is 0.1, end point is 5 radian per second. Third, simple pole. At simple pole 1 divided by 1 plus 0.2s. Therefore plus 40 dB minus 20 dB is equal to plus 20 dB, because simple pole contributes a slope of minus 20 dB per decade. Start point is 5 radian per second, the end point is 50 radian per second. Now fourth factor, simple pole 1 divided by 1 plus 0.02s plus 20 dB minus 20 dB 0 is equal to 0 dB. Start point is 0.50 radian per second, the end point is infinity. Now step 2, phase plot. Resultant phase angle is equal to phi is equal to plus 180 degree minus tan inverse of omega t1 minus tan inverse of omega t2. T1 is equal to 0.2, t2 is equal to 0.02. Therefore substituting different values of omega 0.1, 1, 10, 100, infinity, we are getting these different values. Plus 178 degree, plus 167, plus 105, plus 29 degree. Therefore these are the angles, phase angles. Now again x-axis is logarithmic scale, that is omega 0.1 starting from 0.1 to 1, 1 to 10, 10 to 100, like this. We have to take scale on y-axis. 1 cm is equal to 20 dB and 1 cm is equal to 30 degree. Therefore angles are positive, therefore 180 from bottom will start 0 degree, 30 degree, 60 degree, 90 degree, 120, 150, 180. Therefore at point 1 our angle is somewhat 178, 167, 105 and 29 degree. Therefore join these points by smooth curve. Therefore this is known as phase plot. Now gain crossover frequency, they have given that 5 radian per second. Therefore this is 5 radian per second value. Omega is equal to 5. Therefore from wherever the 0 dB line and this omega is equal to 1, they are intersecting, from that point we have to draw a line equal to resultant slope. This is plus 20 dB from 0 to 5, 0.1 to 5, then 5 to 50. This first line is slope of plus 40 dB, second line is plus 20 dB and third line is 0 dB. Now this gain crossover frequency, from this if you project line, this is the point A, Therefore project point A to the this 0 dB line, and where this omega is equal to 5, they are intersecting, therefore that point is A dash. Now from that point you have to draw the resultant magnitude plot. Therefore draw a line parallel to this, initially plus 40 dB per decade from 0 to 5, then again 5 to 50 plus 20 dB, and 50 to infinity, it is 0 dB line. Now as omega gc is equal to 5 radian per second, it's given, and at omega gc gain line crosses 0 dB line at A dash. The shift of intersection point of omega is equal to 1 and 0 dB line is at a distance of 20 log of k to the base 10, as AA dash, this distance AA dash is equal to 28 dB and the shift is in downward direction, it is treated as negative, that is minus 28 dB. Therefore 20 log of k to the base 10 is equal to minus 28, therefore k is equal to 0.0399 is equal to 0.04 at omega gc is equal to 5 radian per second. Therefore this is the end of the chapter of the Bode plot. Now next chapter we will see, that is state space methods. Thank you very much. Next lecture we will see the objective questions, objective type of test will be there. Thank you very much.